Hey guys, welcome back to OIC Chris, where it's never too late to have an OIC moment. This is part 3 of the November 2021 Maths Paper 1 past paper series that I'm doing, so we're covering sequences and series. If you guys are enjoying the content, then please do consider subscribing to the channel. It does help me out a lot, and let's get into the video. Let's have a look at question 3. So question 3 says, consider the quadratic number pattern, negative 145, negative 122, negative 101. Okay. Now, question 3.1 says, write down the value for T4. So we're looking for the fourth term in the sequence over there. So what we can do is, if I just write this out, negative 145, negative 122, negative 101. Okay, so let's have a look. We know that quadratic will have a second common difference. So if we take the difference between these two, okay, you can see that the difference is 23. Okay, so that's plus 23. Okay, if we look at the difference between this one and that one, it is then 21. So therefore the difference between these two is minus 2. Now we know that the common difference is going to be constant, so therefore if we minus 2 from 21, we'll get 19 over here. So therefore the difference between the third term and the fourth term must be 19. So all we need to do is add on 19 to 101, and we'll get an answer of negative 82. So T4 equals negative 82. Okay. Now 3.2 says, show that this is in fact the formula for this sequence over here. Okay, so we know from our formulas that negative 2a must equal to my second common difference. Okay, so that's going to be negative 2. Therefore, a equals negative 1. Okay. Now we know that 3a plus b must equal to my first common difference over there, which is 23. Okay, so now we're solving for b, so 3 times negative 1 plus b equals 23. And then if you sort out the algebra, that's negative, we take it over, it becomes positive. So b equals 26. Okay, and then lastly we have a plus b plus c, so we need all the coefficients, must be equal to the first term in the sequence, so negative 145. So this becomes negative 1, that there becomes plus 26, plus c equals negative 145. We're solving for c, so therefore c is going to give you a value of negative 170. So therefore in fact we do get that Tn equals to negative 1, so negative n squared plus 26n minus 170. Okay, now looking at question 3.3, it says, between which two terms of the quadratic number pattern will there be a difference of negative 21? So they're asking somewhere along this sequence, if we follow it, the difference between two terms will be negative 121. Okay, so let's have a look. When will that be? So we have the formula now for it, okay, and we need two consecutive terms. So we need a leading term, n plus 1, and we need the term before n. So we need to solve for n. Okay, so let's substitute n plus 1 into everywhere we see n in Tn. So we're going to have negative n plus 1 squared plus 26n plus 1 in brackets minus 170. Okay, this is in a big bracket. Now we're minusing off just Tn, so that is then minus n squared plus 26n minus 170. Okay, and that must all equal to negative 121. Okay, so let's FOIL everything out here quickly. So negative 121. Let's see if I have enough space over here. Okay, so that's going to give us negative outside the bracket, that's n squared plus 2n plus 2 plus 26n plus 26 minus 170. Okay, now we're going to sort out over here. So that's going to be plus n squared minus 26n plus 170. Cool. So this 170 and that 170 is going to cancel out. This 26n and that 26n is going to cancel out. Nice. So what we're left with after everything is the following. The negative distributed in there. Okay, let's do it quickly. equals negative n squared minus 2n minus 2. Okay, then that and that cancels out, that and that cancels out, so we're then left with plus 26 plus n squared. So negative 1 to 1 equals 2 minus 2n plus, let's see, did I make a mess up? Aha, that's not 2, that's supposed to be 1, which means that's 1, therefore that is 25. Okay, now we just need to solve for n, so if you sort out the algebra over there, we're going to get n is going to equal to 73. Okay, so between which two terms will we find a difference of negative 121? Well, that's going to be, now we substitute n back into this up here. So we're going to get between t of 73 plus 1 minus t of 73 will equal to negative 121. So between the 74th and 73rd term, we'll have a difference of negative 121. So T74 and T73. Okay, now the last one says what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern form will be 1. Okay, so remember, quadratic, this expression is a function, and this particular one is going to be a parabola, a sad parabola. So it's going to look, let's say, something like this. Okay, we don't know where the cuts are, but we know it's a sad parabola. Remember, from functions, in order to find the maximum of a parabola, it's its turning point, or you can find the derivative, dn of the function, if you want to be fancy, and find the maximum value. So they're saying that the maximum value, okay, must now be 1. So we can find the turning point of the original function. Okay, so let's find the turning point. So we can use tp equals to negative b over 2a. Okay, now looking at our formula down here, this is a. Okay, so a equals negative 1, and then we have that b equals 26. Okay, so therefore we have negative 26 over 2 times negative 1. So the turning point equals then to 13. Okay, if you wanted to do the fancy way, the derivative equal to 0, you would then find out that you would have negative 2n plus 26 equals to 0. So therefore n equals to 13. Okay, but now they said the new maximum, so tp new, must equal to 1. Okay, so now what do we need to get so that every term, what do we need to add to every term so that the new maximum, okay, is 1? So note here that n, when n equals to 13, we have the maximum. So t of 13 equals to negative 1. Why? If we substitute that in, we'll get that t of 13 equals to negative 1, and that is our current max. But now we want the new max to equal to 1. So we need negative 1 plus something must equal to plus 1. And if we solve for x, we see that x equals to 2. So you need to add 2 to every term in the quadratic number pattern in order to get a new turning point or maximum point of 1. Okay, and that's how we go about solving this question. Okay, if you guys are managing to do this question around 13 minutes, then you're on track for your exams. If not, then you need to practice working under time pressure a lot more. If you are finding this content to be helpful, then please leave a thumbs up on the video. Please consider subscribing to the channel down below. It helps me out quite a lot. If you guys have any questions regarding this section of work, then please leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.